Alright, so now looking at it, the first four questions on our review are about tangent segments. We know that when they meet, they start on the outside of the circle, and they meet outside of the circle, they're the same length. Let me close this line right here. Can you guys see? Yes. Yes. Alright, so we know they're the same length. So what I'm going to do for question number one, the way I'm going to solve this, I'm going to go 5x minus 8 equals 3x plus 14. And then solve for x. We know how to solve for x easily. My 3x, let me move it to the right, to the left, as a negative 3x. My negative 8, let me move it to the right as a plus 8. So we get the 2x equals 22. So x equals 11. To kind of like, just to make sure you guys do know what you guys are doing, last year, I could come and on the radius, right here on the radius, I could include a number like 5, which has nothing to do with the tangent. Like I could throw in a number there just to include it. So you don't do anything to it. Like I said, if I give you a number for the radius, it's just to give you a number. Like you don't need it. It's just there. I think I have a question that looks like that, right? Like number 3. I gave you guys a radius just to give it to you. Don't use it. All right. Any questions on the first 4? All right. Then we move into still talking about tangent segments. I notice that this is 7.2, so this right here must be 7.2 as well. Looking at the whole side is 14.6. Part of it is 7.2. I'm going to say the remainder is 7.4. Right? I subtracted my two values. Since this is 7.4, I'm going to say this other side right here, it is 7.4 as well. Then I look at the whole thing. It's 15.4. Part of it is 7.4. I'm going to say the remaining is 8. So I'm going to say this little side right here should also be 8. Now for the perimeter, this whole side is 14.6. This whole side right here it is 15.4. And this whole side right here it is 15.2. Add everything, and that's your perimeter. Welcome. So this, yeah, you guys get 45.2. Right? Alright, so far so good, but not bad. So in fact, when we covered tangents, you guys came and said it was not that bad. Alright, so that was the easy part. Then we move into this part. Now this one, the way we're going to work this one out, let me just pay attention to a triangle. And what I'm looking at is this triangle here. That's the triangle I'm looking at. I know the two sides are radius, so I'm talking about an isosceles triangle. Because we're dealing with an isosceles triangle, I know this side right here it is 63, this angle. I could even find this center angle here. I'm not going to do it, but I could find it. Then I know this corner right here it is 90, because a radius and a tangent, they cross a 90. From the 90, part of it is 63. I'm going to say the remaining, so this part is 27. Because together they make 90. Right? These two angles right here together make 90. One of them is 63, the other one should be 27. Right? 90 minus 63 gave me 27. Technically, we could find every angle there. You guys saw that was 27. I told you guys we could find this center angle. We don't need it, but we technically could find it. I could ask you guys for this other angle here, because 63 and this angle, they make 180, because it's a straight line. So I could ask you guys for this angle. You guys could figure it out, right? 180 minus 63. We figured out that this one's 27. I could even ask you for this other one. For this one way you can find it out, see this blue one, you can figure it out, right? 180 minus 63. This little one is 27. a triangle, the three angles add up to 180. If you already know 2, subtract, add those 2 and subtract it from 180. So technically, I could ask you for any angle in there. Now this part was not that easy. Now here, the 34 is this little angle here. It looks way out there because it didn't fit at the corner. So that's a 34, and I'm asking you guys for this. So it will be subtracted from 180 if 34 was this corner. But because it's not, I'm not going to do that. One thing that I can do is look at the big triangle. One angle is 34, another angle is 90. I can find the third angle. Right, I'm looking at the big triangle. I know 2 angles. I can find the third one. Right, we're gonna call this 56. But the reason why we came out with the 56, because we added these 2, so 124, and subtracted from 180. So that's how we came out with that 56. But now I'm gonna find the angle that I'm being asked for. So let me call this angle X for right now, because I don't know how big is it. The cool thing on that one is this other one right here, it is also X. Right? We're dealing with an isosceles triangle here, so these 2 angles are the same. So I call one X, the other one is X. So now, if you add the 3 angles, I'm looking at this triangle here, you have 2X plus 56. Right? I added the 3 angles, and that is equal to 180. Now you can solve for X. I subtract 56 from each side, so that gives me 124. X must be 62. But the idea on this is, if you have a triangle, you know 2 angles, you should know how to find the third one. Yes, Luis. 11? Less. Now look at a number 11. Let me find this angle. But for that, I'm going to use the big triangle. I know this corner here is 90, because remember, a radius and the tangent across a 90. So I know that corner is 90. This is 53. I know 90 plus 53 is 143. So for me to find this angle, I'm going to go 180 minus 143. 37. So this corner is 37. The cool thing is that this other corner here is 37 as well. Because if you notice, I'm looking at an isosceles triangle. It's radius and radius. So now, the one I want is X. I'm looking at the triangle. I'm going to have 74 plus X equals 180. The 74 because I added the 37, right? 37 and 37 together is 74. So 74 plus X equals 180. We can find X. So you're dealing with triangles in there. Some of your triangles are isosceles triangles. Like the little one, we know this leg and this leg is, they're isosceles. And I said some of them, because not all of them. As the big triangle, that is not isosceles. So this is what you have to remember. And we know they're isosceles, the little one, because a radius is equal to another radius. So that's why we know the lengths are the same. What was it? X equals 106. Okay. Now when they're simple, number 12 were the easy type. Now these are simple. Because we know that this corner is 90, this corner is 90. I know the 4 corners together is 360. So 360 take away 90, that's 270. Take away the other 90, that's 180. So I know these 2 angles have to add up to 180. So less than 97, right? Yeah. Less than that? Oh. So, okay. 97 sounded a little too big. So remember, when we're dealing with a kite, and the two corners are 90, because I know the whole thing is 360. I took away 90. I took away the other 90. That's how I was left out with only 180. I know those two add up to 180, so it's 69. All right, now any questions up until number 14? 14? All right, let's take a look at 14. I know that this corner up here is 90. Let me look at the big triangle. So I'm going to find out how big is this angle here. Say 38. Okay, so let's call it 28. The way we came out with the 28, because we know the 90 plus 52 is 142, right? Remember, when you have a triangle and you know two angles, add them, and then obviously subtract it from 180. So 148, oh yeah, it's 38, right? Yeah. Just checking if you were awake. Yeah. All right, so that's 38. So once again, the way we came out 38 is we added these two, 90 and 52, that's 142, subtracted from 180, so we got that was 38. Do we know how big is this angle here? This is 38. I'm not going to find, I could find this one if I wanted to. I'm not quite going to find it because I don't need it. I'm looking at these two angles, 38 and the 190. Notice how together it's half of a circle. So together they're 180. So I'm just going to say that x plus 38 is equal to 180. So I can solve for the angle that I need. $142? Okay. As a suggestion, what you're supposed to do, what I will do if I were you, like from the beginning, look at which angles can you get. Just quickly you can get this one is 90. Based on those two, you can get this other one, which is the one we got. Remember we said that's 38. Alright, so if that's 38, that gives me this is 38. Now, 38 and x, I can combine them. Then I can work x. Does that make sense? Okay. Any other questions up until 14? Okay, so make sure this section seems like we need some reviewing. Make sure you review that section. Then we move into chords. We started with them easily. If there was part of a diameter, right? This is part of a diameter. The chord that it crosses at 90 degrees, the two sides are equal to each other. So we're gonna say x equals 19. Like I said, we started easily with the chords. That was not bad. Number 16 shouldn't be that hard either. Yep. 17, 18 are not hard. But now, number 19, we're going to pick up the notch a little. Because x is this little side. So I'm not going to say x equals 12.3, because this right here is 12.3, not x. However, x with 6.6, that's a radius. So I'm going to say x plus 6.6, that's a radius. I'm going to let it equal to the radius. Then I'm going to use this 28 for that. I know the whole diameter is 28. So that means if you break it in half, this is 14, this is 14, so the radius is 14. Now we can work for x. Right, x plus 6.6 equals 14. So 14 minus 6.6, so gives us what? 7.4? So look if your x is part of a radius. Looking at number 20, this is x with 8.8 is radius. Together they're radius. So I'm just going to say x plus 8.8, that's a radius. How big is the radius? 17.6. And then you can easily solve for x. Right, I gave you this radius and I gave you this other radius. You might ask me, well, what is the 15.3 there for? It's just to let you know that this is 15.3. You don't need it, but it's there in case you wanted to know. So that was not that bad. But then we move into something like 22. Oh, no, not 22. 22 is still easy. 25? Or 23, actually. No, 23 is easy. Yeah, you were right. 25. I could easily say x is a number if I knew how big this other side was. If I knew. But I don't. X is not part of a radius. However, I see a triangle, a right triangle. I know two sides. I can find out the third side by Pythagorean theorem. So before I set it up, I look at my three sides and then circle which one is the biggest of the three. Right? Looking at length, don't look at the numbers, look at the length. I know that's the big one. So the way I'm going to set it up will be x squared plus 8.2 squared equals 22 squared. Right? The big one is the one that goes by itself. It could be a number, it could be x. And then from there, work it out. I don't have my calculator, so I don't know what 8.2 squared is. 64 point what? 67.24? Okay, so you guys get that x squared plus 67.24, 484. Subtract 67.24. 0.76, okay. Now the last part, do the square root of it. So what's the square root of 490? What is it? 20.5. Just as a little thing to double check, on the triangle, remember I said 22 was the biggest? So your answer should be less than 22. So 20.5 makes sense. If we would have gotten something more than 22, it doesn't make sense. Okay. Now this one, the Pythagorean theorem kind of gave you a little trouble. Any questions up until 26? No? All right. Now to the last sections, looking at number 27, we came in and we want to know this angle. The angle's on the corner, so this angle creates this arc. It would be nice if I knew how big this arc was. Do we know how big is the arc?
Yes.
How big is it? Starts with a 100. 148. If you're wondering where the 148 came from, that angle, that arc, and the 212 is a circle. So we just went 360 minus 212, so we got 148. All right, so remember, I need the angle and the arc that it creates. The way I'm going to set this one up will be x for the angle equals 148 for the arc divided by 2. So 74. That's it. Remember, when the corner of the angle, it's on the circle, this is half of the arc. You notice the angle, it's half of 148. 28? All right, let's look at number 28. The angle's outside. I need to know my two arcs. One of them is 235. How big is this little one? 125. And the 125, because it's the one that completes the circle, so we just went 360 minus 235. So that's how we got the 125. So always start with the angle. This case is x. X equals, in my fraction, I'm going to go 235 minus 125. Always start with the big one. Over 2. I'm not going to get rid of fractions because I can simplify my fraction. 235 minus 125 on the top. That's 110. X equals 55. Good. So the first four were just numerical. It was not that bad. Some of the angles could be inside, like the number 29. But instead of subtracting the arcs, you add. So that's not bad. But then let me take a look at 31. Where there's pluses or minuses in the angle or the arcs, we always start with the angle. So 42x plus 1. We always start with the angle. My fraction, 68x plus 50, good, over 2. Since the angle is inside the circle, we add the two arcs. Right? We add. So that's why we have those. All right, since there's an x on my fraction, I'm going to get rid of fractions by multiplying both sides by 2. So the left side is going to be 84x plus 2. And I multiplied everything by 2. Equals 68x plus 50. So now we can easily subtract 68x. We can easily subtract 2. How much is 84 minus 68? What is it, 16?
Yeah.
50 minus 2 is 48. So what's x? Good, x equals 3. So this, if you notice, is the unit, the whole thing that we reviewed. I know the last part, the angles inside on the circle, outside, was what killed you guys the most. So that's why that one we saw the most. The review tomorrow, like today, I made each section, or we're missing the last section on this one, but I made each section about the same size for today. The review tomorrow, the easy sections I'll make them small, the hard questions I'll make them big. Because I think on a review, the purpose of a review is practice what we need help with. So the easy questions we don't need that much help with, so there's only going to be a few. The hard questions, it will be a few more. Right? Because we need to practice what we need help with. Now, let me just finish this with my last section. Question number 35. We're looking at the length of the arc. So I think of circumference. The radius is 13. So the circumference is 26 pi over 1. Right? Radius times 2. I'm going to multiply this by 45 over 360. How much of the circle you got? If you have those calculators that simplify fractions, just multiply, you're good. If you don't, let me simplify. Let me divide each by 45. So I have a 1 on top. 360 divided by 45 is 8. Then diagonal, the 8 and the 26, I can divide each by 2. So this is 13, this is 4. So when you multiply straight across, 13 pi times 1 is 13 pi. At the bottom, 1 times 4 is 4. But if you have your calculator that does fractions, don't worry about simplifying, your calculator does it for you. Now, any questions at all? We'll be good on Friday? Yeah. Okay, let me take roll really quick.